When we started to design J-trac, it's roughly 10 years ago, somewhere around there, we designed it to solve two problems. One was the risk of attaching a ligature, and the other was also to avoid any sort of risk of self-harm being conducted by using the rail. So how did we go about that, and what was the issue? So one of the issues was that there had been incidents and there were problems with the type of slotted rails. People, users, had found out that you could use a coin or you could use something else and attach that to the slotted rail and then put your full body weight there and it would still stay. So that was a risk. And when we started as designers to look at this, we sort of do what we usually do in a way, is sort of, in this case, not thinking outside of the box, but thinking outside of the slotted rail, because that's sort of the predominant type of rails. You explained that as well, Tony, saying that the J-trac is a monorail. And I will show you the profile soon, and you will understand why that design is different. When we developed this, we did that in a dialogue with Rampton High Secure Hospital and Vadstena Rättspsykiatri in Sweden. So we had these experienced people to discuss with while we were developing it. Also, we needed to find out sort of what risks would there be, what would they see, what would they use. What's also positive is, of course, that they wanted to have curtains. As you mentioned, Tony, curtains are not only sort of there to shut out light, even though that's really important for the autonomy. I remember I visited a prison in Norway where there was an elderly client there, and there was this massive light just outside her window, and she was difficult for her to sleep, and there was nothing to shut out the light with, and everything was broken and so forth. But curtains are also easy that way, because you could just, put them up again or pull them down, and that's actually another point. That's where J-trac is pretty suitable, is that if you need to take out the curtains easily, you actually just pull them down. So what is it then with these types of rails? So when we started to work on the design of the rail, we started to look at a design of the sort of ordinary slotted rail. And this void in here is apparently a risk because there is room here to attach something. We looked at different types of gliders and so, but we never got around this problem here where you could see this is just a standard rail and there's a pencil in here and there's a shoelace there. And I could really put a lot of weight there. Or I could use a paper clip or something and attach it. So we needed to work around that. And when we're designing, okay, we're thinking of different ways. Maybe we could invert the whole idea of the profile of the rail. So I went down memory lane and found a good box with things here. So this is one of the early versions of J-trac. It looks more like a T-trac, maybe. The risk with this, though, we realized is that it works pretty well, but what happens is this, that you're creating a negative spacer void where you could attach something here between the wall and the window here and the rail itself here. So how are we going to get around that problem? That was really an issue for us. And then we thought that, okay, what happens if we remove the problem? So I'll see if I can show you. What we did is that we removed this part here and ended up with this profile here. And this profile here, we also made an open angle here, so you can't jam anything between the rail and the wall here. So that was a solution that actually we first thought is not going to work, because if it's only hanging on one part of that sphere, it's going to fall off. But it didn't. It just didn't. And the profile then, let's see if I have some of the early versions here. Well, here's another one, which we sort of let go. So actually, this is the profile. I think this sort of illustrates best how the rail works, where you could see the profile like this. The point also with this was that it's impossible to attach anything around here, really, and fasten it. It's easy to clean, and you can see it's solid aluminum. So we extrude the aluminum here. We work on it. It's powder coated, and it's a really, really high grade of powder coating as well. So when you attach the runner to it, it glides really, really well. It glides so well, actually, that there is also a version where the last runner stops at the end of this, which we call the end cap. And all this is also solid aluminum. It looks like this when it comes out of the extrusion. So it's really solid, but it's still not chunky. It's slim. We want it to look good. So this is top fix. We also have created a wall fix version that looks like this. And we also realized that we needed to do something with the design of the end cap. So if you could see here, there is a slight angle. So where you have the wall here, you're also again creating an open angle to minimize the risk of anything getting jammed there. But let me get back to what we did then. We did hundreds and hundreds of different types of kinds of ideas of different types of runners. We made them all by hand. We used, well, this one's actually 3D printed, but when we made them by hand, the idea is that you could use the right type of material, more or less. So when these are injection molded, you know that this is the right type of material. And it's not sort of an ordinary, cheap, everyday plastic. It's really a high quality virgin type of plastic that we use. And it's strong and it's flexible. Another issue was that with a runner, what happens if people swallow it? So we had some discussions with people from forensics and asked them, and actually we got a good answer, which was that anyone could choke on a grain of rice, but a lot of people could also swallow a fork. So size-wise, no sense to really consider doing something huge, but to do something that's really rounded and soft, that makes sense, and where they don't gang into each other. So that's why we designed it this way. Another feature that we realized, and you were touching on that, Tony, what happens if you gang a lot of runners together? This one here, I'll show you. This is roughly somewhere around, I'll pull this here, somewhere roughly 1.3 kilos. If I have 10 of these, is the load then 13 kilos, and I have 20, is it 26 kilos? No, it's not. If you have 10, 20 or so, somewhere around 6, 8 kilos anyhow. How come? Well, it has to do with the design of these and what happens. And there's one special feature. If you could see here, and I hope this works, you can see there is a small sphere here at the end. I've just drew an illustration for you here. You could see that the orange part here is a sphere, and there's one on the other side too. Though they are actually positioned like this, they're not exactly in line with each other. And so when you put a bunch of runners all together, they start to do this. And when you put too much load there, it releases. So you don't multiply the load, and that's been really important for us. So this was a way of thinking of something and doing it not the usual way, which the solid rail would have been. I also want to add one part there, and you were touching on that, Tony, which has to do with the angle, how something releases. So we usually measure a lot of things just pulling straight down, but that's not really what happens. And when we've done tests here with the Test Institute, they actually also need to test what comes in this angle or that angle or sides. And that's really important. And J-trac releases in all these angles as well. What else could I add? It's actually patented. We didn't think that would be possible, maybe inverting a shape, but yes, and altogether, it's a patented product. We have several versions. I showed you the top fix, the wall fix. There's also one version which is a bent with a radius of 400 millimeters, and it's a 90-degree bend. And that makes it usable for showers and shower curtain, because a lot of these facilities, they have contacted us and we have problems. Everything is getting wet. It's more or less rotting. We need to change the threshold. It's fairly new. So the usage of a shower curtain helps a lot. And it also has to do with privacy for the patient and so forth. We could also bend them in different ways, so they could follow a niche, or they could actually do this and that. So that's something that we've developed along the way as well, which we didn't have initially. We also have used the profile in wardrobes, and we have designed a hanger that snaps onto the profile as well. So the usage of J-trac is really wide. And the name I think we have to credit Anthro Ligature Shop for is J-trac, is because again, this is the profile that we invented, and it's a J.